This problem appears like it might be more difficult, and that's because of these fractions that we're dealing with in it. And honestly, our goal still is just to get the bases of these exponential expressions to be the same. So we don't really have to worry too much at their fractions. We just want this 16 to match up with the 64. But if the fractions are really messing with you, what you could do is you could flip the fraction as long as you do the opposite of the exponent. So if we multiply the exponent by negative, so I could rewrite that as 64 to the positive 8x minus 3. And on the right-hand side, I could rewrite this as 16 to the negative 7x plus 2. So all I did was the opposite of that exponent. Made that a positive 8x and a negative 3. And I made this a negative 7x and a positive 2. So now from here, how can we rewrite that 64? Well, think about 16 to what power is 64? And that's kind of difficult, but I'm picturing right now that 4 cubed, I remember 4 cubed is 64, right? Now, how can we get 16 down to a 4? Well, the square root of 16, is 4, right? Well, if we cube the 4, then we'll get our 64. So 16 to the power of 3 with an index of 2 would be 64. So I'm going to go ahead and rewrite that 64 as 16 to the 3 over 2. Then we got to go ahead and multiply these exponents. So I'm going to have 16 to the 3 times 8 is 24 over 2 is 12x minus 3 times 3 is 9 over 2. And now that we have the same bases, we can go ahead and set the exponents equal to each other. And I'm going to go ahead and add this 7x. And actually, before I did that, I should have got rid of the fractions, but it's okay. I'm going to go ahead and do it now. So I don't like having that 2. Let's just multiply everything by 2. So this side's 4. That's nice and easy. And 19 times 2 is going to be 38. And then we multiplied that by 2, so the 2 on the bottom just goes away. Then I'm going to go ahead and add the 9. And then divide the 38. And x equals 13 over 38.